Good morning, class. How are you? Yes, I am also fine. Now, we are reading the circle chapter. We have finished almost all the important theorems. Now, some important topics are remaining. So, one time we can just have a recall there. Okay. These are the members of a circle: tangent, secant, chord, time. We have solved questions based on this also. Arc. This is a very important theorem. Also, we have discussed arc theorem. These are the definitions we have learned in the previous videos there. So now this is called the segment, major and minor segment. The green one is the minor, the white one is the major segment only. So these all things we have learned. Okay, we have learned about the sectors, we have learned about the concentric circles there. So no need to revise this again. You can just revise at your home very nicely there, because all things are there in the previous videos. This is the chord here. If it will be extended in either direction, it will become a secant also. So these all things, see, this will become a secant here. So today what we are going to discuss then? Today we are going to discuss this. This is very important theorem. Angles in the same segments are equal. Angles in the same segments are equal, and this is very widely used, and we'll discuss also in the classrooms these things there. Okay, how we have proved this, but in this topic that we are going to discuss today, in that this will be also used. We have used to prove cyclic quadrilaterals opposite angles are sum of opposite angles are 180 degree. We have proved this with the help of this same segment theorem. So these all things we have read. So what we have to read today? We have to read about this one. This is cyclic quadrilateral. Okay, so what is the cyclic quadrilateral? So this is the cyclic quadrilateral here. A cyclic quadrilateral is a quadrilateral whose vertices all lie on a single circle. That means this is a circle here, then all this will be called a cyclic quadrilateral whose all vertices, say vertices 1, 2, 3 and 4, all vertices will lie on the circle, and these vertices are said to be concyclic. Okay, these vertices will be said to be concyclic. What are the properties of this cyclic quadrilateral? So this is the property of cyclic quadrilateral. You can see here that in this, the blue one are the opposite angles. Clear? That angles which have been drawn blue, these are the opposite angles, and their sum will be always 180 degree. See, with the examples also I have tried to prove this. The one blue is 85 degree, one blue is 95 degree, so total sum is 180 degree. Now see that orange one here, that red one, one angle is 102 degree, second angle is 78 degree, so total sum is, opposite angle sum is 180 degree. So this is the cyclic quadrilateral. Okay, and we are going to read this here, and we are just going to use this concept in our question. So I have made one video, I will like to discuss with you there. Just see this. This is one question that I have made. Wait a minute. I would like to explain this question first, and then we'll start this. Okay, wait a minute. Question is saying that the sum of all the angles in 4 segments exterior to a cyclic quadrilateral is equal to 6 right angles. Okay, so here is that figure I'm going to draw, and I'll say about that exterior angle also. Say this exterior segments of a cyclic quadrilateral. So this is one circle. Now I'm just going to draw the cyclic quadrilateral here. Okay, I have drawn this cyclic quadrilateral. See, all the vertices are on the circle only. Okay, so let me complete the figure first, and then I'll explain this all. So which I am drawing right now, no, that is the exterior segment of a cyclic quadrilaterals. These are exterior to the cyclic quadrilaterals, and this ABCD is a cyclic quadrilateral itself. Now, so what is given? So given is a cyclic quadrilateral ABCD, and these angles which I'm writing right now, P, Q, R and S, these are the angles in the exterior segment of a cyclic quadrilateral. Yes, obviously these all parts are exterior to the, see, this is exterior segment, this is exterior segment, this one is exterior segment. So these angles has been made in the exterior segment of this cyclic quadrilateral. So we have to prove that the sum of these all angles, we have to prove that here, that sum of P, Q, R, S, that is equal to 6 right angles, means 6 into 90, that is 540 degree. Okay, so we have to prove this. Okay, so we'll prove this. P, Q, R, S is equal to 540 degree. Okay, so we'll start the proof here. It's looking very lengthy, but it's very easy only. We have to make one construction, we have to do one construction, and it will be solved there. Okay, so what is that construction? Construction is that we'll decide in this figure, I will take point S. From there I will join S to B. From here S I will join S to C. Okay, so one thing I think you may be visible there, that it is looking like triangle SBC here. So that will give me 180 degrees. So let us see what will happen here. So now, one thing I would like to say here, this point is S here, this is S point. It's not visible there, but this point is S point. Clear? So this angle I am labeling there, angle 1, 2, 3. This is already angle R, this is angle 4, this is angle 5. Okay, now we will start the proof. What they have asked, we are just going to prove this. Okay, between A and D, that vertex is S here. Don't get confused there. Where is the S? So first of all, this ARBS is a cyclic quadrilateral. Obviously all the points vertices are on the circle there. So that means opposite angle sums will be 180 degree. That means angle 1 plus angle R, that is equal to 180 degree. Similarly, this one more cyclic quadrilateral we are having, that is in the downside, it is S, D, C, S, D, P and C. Okay, that is the one cyclic quadrilateral. Okay, so the sum of angle 3 and angle P will be equal to 180 because these are the opposite angles of a cyclic quadrilateral. Clear? Very good. Now see very minutely, we'll see that SBQC, SCQB is also a cyclic quadrilateral. All these vertices are on the circle, so they are concyclic. So we can say that angle 2 plus angle Q, that is equal to 180 degree. And these are equations, 3 equations we have got. In all the equations we have got 180 degree. That means if I will add 1, 2 and 3, I will get 540 degree. That one thing I am very sure. So we will go on that method only. That will add 1, 2 and 3. Okay, so what will happen if I'll add 1, 2 and 3? So angle 1 plus angle R, that is in equation 1. Angle 3 plus angle P, that is in equation 2. Then we have angle 2 plus angle Q, that is in equation 3, that is equal to 180 plus 180 plus 180. 3 times 180 is there. Okay. Now, angle 1 plus angle 2 plus angle 3 at one place. Angle P plus angle Q plus angle R, that at one place, that is equal to 540 degree. And angle 1 plus angle 2 plus angle 3, that is equal to angle S. I have explained where is that point S is there. So angle S plus angle P plus angle Q plus angle R is equal to 540 degree. And we have proved also. Okay, we have just proved angle P plus angle Q plus angle R plus angle S is equal to 540 degree. So in this way we have proved our theorem. All these, see, which I am doing red, this is the last one, is the point S there. It's not visible, sorry for that, but we have just proved only. So this is how we have proved using that property of cyclic quadrature, that the sum of opposite angles is 180 degree. We have proved this question. So you just revise nicely, and in the next class we'll learn something new, some new topics we'll discuss. Till then, all of you take care, take your class. Thank you very much.